this is going to have to do with the percents and sales discounts. And before I get into the question, I wanted to also point out that I am not going to assume what your relationship with math is like, and I am going to try to say the same thing in different ways. But, I don't want you to feel like there's pressure to understand it in any particular way. If you are the I have to just use my calculator and type things in kind of person, the how-to, that's totally fine. Of course, I have a natural bias toward calculations and actually writing out the math notation, but I also just kind of ask that you are also respectful of people at all different levels, and yeah, I have to get that out of the way because sometimes I don't know who exactly I'm explaining things to, and so for some people it might just be okay, I get it, and for other people it's, it's the first time that they're seeing this, or numbers get all mixed up, and I really just want to make sure that we feel safe and comfortable here. And yeah, okay, so I'm saying that more for myself, but in case you need the permission to also not worry about every little detail if you don't want to do, but also the encouragement to try to see things differently if you're interested. Okay, so 100% of something is the total. 100% is 100. 50% off means that you are left with 50% of the original price to pay. And that's why you pay $50. That's also why 50/50 means like you're splitting it in half. So half of 100 is also 50. Just different ways to look at it. Okay. So if we do the 40% off and then an additional 10% off, I should mention that this interpretation is what I've seen more of in terms of like the practical application. But of course, if you see this exact sale, you should read the fine print. Maybe it's a different case where they happen to be the same. But in this way, we'd have $100, let's say is the original price. Taking 40% off means that I get $40, 40 of the 100, right? 40% is the flat amount of dollars off, meaning that you pay $60. So 100 minus 40 is 60. But then it says an additional 10% off. Now this additional percent part is what's left for interpretation. But in this case, when we're saying an additional 10% off, we're talking about 10% off of this amount now, which is interesting. So now we have to do a percent of this number, and it's 60, so it's not quite as straightforward as saying, 42% of 100 is 42, but 42% of 60 requires a little bit more math. That's okay. But if I say an additional 10% off, for those of you who like the how-to, I suppose, without doing the math, the 10% off just means you can, if you see 60 here, you can pretend that there's a decimal point right there, because it's 60.0000, that's all the same. Or in dollars, it would be $60.00. But when I do 10% off, I just move the decimal over 1, and that gives me 6.000, but that's just a 6. So 10% off is 6. Okay, so that's another 10% of this after the 40% off case. So again, if it's 40% off and then an additional 10% off of the original price, that's different. That would be 50% in total. But a lot of times this is 40% off and then an additional 10% off. So that's how you do this. And then 60 minus 6 is 54. And you can do that from here. That's 10 minus 6 is 4. You borrowed 1, that's 5. And that has to do with long subtraction, I suppose. But you can just do that in your head or with a calculator. But that is how much you would end up paying in this case. So that means that I would rather pay $50 rather than $54 for the same thing. So I would rather the 50% off flat case rather than 40% off and then an additional 10% off. Okay. So now we are going to do this for general X, an original price of X. This is where we are going to work with decimals. Again, some people prefer fractions, some people prefer decimals, some people prefer to just type this all into your calculator. As far as percents go, I have another video where we go from percents to decimals. So you put a decimal point wherever it is. If you don't have one, if it's like 42.5%, then you already have a percent. But if you don't have one, then you plop one in at the end of the number, because you can pretend that there are a bunch of zeros after that decimal. And then you move it over left, shoop, 2 over, and get rid of that percent, just because it literally is working out of 100, and that's how you divide by 100. So this has everything to do with decimal and how the base 10 system works. For those of us who want to generalize this for any price and using decimals, I was thinking that this might come in handy for anyone who might be reviewing for like the SAT or standardized tests like the ASVAB or maybe something like that. I don't know, maybe even the GRE. Just this kind of notation can come in handy because a lot of times we will use this expression for the rest of our problem. So being familiar with this can come in handy. I don't know, but let's say X is the original price now. So instead of 100, we have X. So let's say we have the 50% off discount. So that would mean that what you can do is you can do, let's see, so 50% off of X. Lots of different ways here, but for one, we said that you can convert this into a decimal. So that would be plopping a decimal at the end of that, moving it over to, and then getting rid of this percent sign. So that would be 0.5 off of X. So of X means to multiply it by X. So 0.5X is the flat dollar amount of what you get off. Another way to write that is to take the 50 and put this over 100 out of 100. And if you prefer to work with fractions, that simplifies down to 1/2. If you divide the top and the bottom by 50, you get 1/2. So that's why we have a 0.5, we have 1/2, those are all the same. And you could do half of X. So when you have of something, you multiply it. So 0.5X is the dollar off. So whatever X amount is, you could have something that starts off at $25, and you would just, in your calculator, if you wanted to, put in 0.5 times 25 or something like that. That would be $12.50. Okay, so that means that you take your original price. So being clear with if you are paying 50% off, or if you're getting 50% off, or if you're paying 50% of the price. In this case, 50/50 is nice and even, but if you are, let's say you get 30% off, that's not the same as paying 30% of the price. I wish, right? So in this case, we have 50% off, so you have the original minus the 50% off price. And so that means you can, the total amount that you actually pay, you can factor out this X, and this would be a 1X minus 0.5. So this is a little combining and simplifying like terms is what I mean. So 1 minus 0.5 is 0.5, so you pay 0.5X is how much you pay. So depending on your preferences, either this is nice and clear, I suppose, or this is just way overcomplicating it. It really is. Different people think differently, but I always like to depend on the math, so this is like my preference for this case. I think for the 50% off, it's kind of overcomplicating it, but because it's literally 50/50, but for other numbers, it's kind of a quick little subtraction question. So for 50% off, you can think of it as this thing, but basically what you're doing is saying, I'm going to take the whole thing, which is 100%, and subtract 50% off, which means I pay 50% of the thing, if you want to just jump straight into the percent part. So for instance, when we do the 40% off and then 10% off, you can do the same. In fact, you could even write a formula from this 100 minus percent off times your original amount. But if you have 40% off, you could do this as minus 0.4x, because 40% is 0.4 and 40% of x is 0.4x. So this would be off, and then you would have 1 minus 0.4 what we did, which is 0.6x. So basically, 100% is the total amount, the total original amount cost, and then 100% minus 40% is 60% of your original amount. So 0.6x is what you would pay after the 40% off, and then the 10% off of this, you can do 100% minus the 10% off, meaning you pay 90%, right? 100 minus 10 is 90% of this thing. So 90% of that is what you would pay, which means you would do 0.9 times 0.6x. And if you do 0.9 times 0.6, that's 0.54x, which is 54% of x is what you pay. So 0.5x versus 0.54x, that means you would pay less for this particular case. Okay, so I don't know if you like seeing these decimals. Also, it might look weird. I don't usually do the 0 point, but if you are like working on a spreadsheet or something and trying to write this all out, definitely make it so that you recognize what the percents look like. If you need to do 1.0 minus 0.5, that's okay. Make sure you're lining up your decimal places, but this is usually how I like to think of it. In some way in my head, I am doing either 100% minus the percent off to see what I'm actually paying, or I'm doing 1 minus a decimal, or just at least keeping in mind, of course, as you work through this, it gets faster. You don't have to keep relying on this over and over. But the key thing that I want to emphasize is to keep in mind, first of all, if you're working with a percent of something, or if you're working with like a flat number of dollars off, make sure that if you're subtracting things that you're not doing a flat number minus some percent. You want to do either flat number minus the flat dollars off to give you a flat number of dollars that you're paying, or you can deal with percents altogether, remembering that the original total amount is 100% minus whatever other percent you're dealing with. And then another little thing is to be clear with if you're talking about some dollar amount off versus what you're paying and the percent of what value. And so in this case, when we had 0.6x, that is because we are trying to keep everything in terms of x. But if you needed like an intermediate step, you could set this as y and say 10% off that y, but then you would trace it back to that original value. So you don't have to let the x or the variables and stuff scare you. Just remember conceptually that this 0.6x is what you end up paying relative to this original x price, but that whole thing is a dollar amount, and then when you take an additional 10% off there, you treat it as though that whole amount is one thing. So either way, assuming that you don't want to pay more than you have to for the same thing, you would take the 50% off flat. So there's some cool questions with this, like whether you want to take a flat dollar amount off or a percent